Hope I'm here. All right, so we're going to do, this is on the back of the 1.7 packet, and it's our free response question number 4. Remember, I lost 2 and 3. I don't know where they are, but here we are at the 4th one. So, pictured to the right is a graph of a piecewise function that consists, okay, this is G, you guys. I see 2 different functions, so we need to make sure that we use the graph whenever it asks us about G. And okay, they're telling us it consists of a square root function. So that's here. I wonder if they're going to make us write that. That's what we had to do last time. And a piece of an absolute value function. Do you see that one here? Okay. Also, we love the word also in math. Also, the function p is defined by this equation. Okay, so we have a piecewise function called g, and then we have this p. And A says, now I know you guys are all scared. You're like, oh my gosh, this looks so hard. But then look at it, just says state the domain and range for function G. So I want you to practice writing the domain and the range now. Practice on your own. I'm actually going to pause it because I want you to practice first and then we'll check our answers, okay? Okay, so the domain, it's going to be the x value. So what is the smallest x value? What we're looking for is an arrow. If you have an arrow, we would write negative infinity. Do we have an arrow or a point? A point. So the lowest x value we see, this graph begins at -5. And is this open or closed? Closed. Good. So we're going to have a closed bracket for -5. Okay. Now, follow the graph. The domain is every x value that has a y value. So, point. There's a hole. Okay. Does the number 1 have a y value? No. So is 1 in the domain? No. So here's what we're going to do. We're going to close our interval off at 1, put our u, and then open it back up at 1. So what we did is we're jumping over 1. Okay, from 1, now I'm back on the graph and I see a y value, point. This is still a point here, it's just a turn, so there's still a domain. The domain is there a y value for each x value? And then we keep going, and now on the ends of the graph, remember we're looking for a point or an arrow, and what do we see over here on the right? An arrow, yes? So an arrow means it's going towards positive infinity. And that's going to be our domain. So the way that goes is positive infinity is to the right, negative infinity is to the left, and for the range, negative infinity is down and positive infinity is up. Okay, let's talk about the range. Range are what values? Y value. So the y value, but it has to have an x value. So look at the smallest y value. What's the smallest y value we see? -4. And is it open or closed? Closed. So it's going to be a closed bracket. And now we're going to travel up. So I'm going up. I'm going up and up. And this y value is 1, but does it have an x value? It doesn't have an x value here. Does it have an x value somewhere else? Yeah, so is 1 in the range? Yes. Okay. And then we're going up, 3. We get to a maximum of 3. Are there any y values above 3? No, so 3 is our maximum. And is that opened or closed? It is closed. Okay, let me just check my graph. Uh-oh. There's an arrow here. What does this arrow mean? It goes on forever. So it goes this way, this way, this way. There I am, writing on the desk again. Okay, so the answer I have written down is wrong. What's the problem with my range? It keeps going, and where does it goes, do you see how it goes past -4? And where does it go? Negative infinity. So if you wrote -4, like I did, we need to erase it and put negative infinity. So you have to check both sides of the graph for the arrows there. Okay, that's our domain and range, and we need to keep going because I only have 15 minutes and I'm at 5 minutes. So state how the graph of the function p would be different from the graph of that. That was our quiz, yes? Describe the transformations. So let's look at p. If p has a negative in front, what does that mean? So reflected over x-axis. The +4 in with the x means it moved left 4. And the +1 on the end means it moved what direction? Up 1. Okay. State how the graph of p would be different from the graph of y equals square root of x. Then what do? Graph p on the same grid as g using a minimum of 4 points plotted on the graph. Okay, so we need to graph a square root function that's been reflected and then moved left 4 and up 1. Okay, so let's go left 4 and up 1. Normally, you guys, the graph goes like this. It goes like an arm up, but it's been reflected down. So instead of going up, we're going to go down. And here's this point. And then the point goes over 4 and down 2, because that's the square root. The square root of 1 is 1. The square root of 4 is 2. What's our next point going to be? The square root of 9, and then down 3. This is our p function here. Okay, state what would be graphically true if p is equal to g. Well, if p is equal to g, that's where the p graph has the same x and y value as the g graph. So it's the intersection point of both graphs. If p equals g, that is the intersection point or points of both graphs, of both functions. It's really one graph. Two things are grafted. Okay. How many times does the pink, oh, I did pink for P. The phone, I'm working here. How many times does it intersect? Okay, so how many times does P intersect? It didn't ask us to find the values, it just says how many. Do you guys see that? How many? There are 2. There are 2 x values for which P equals G. Okay, D, find the value of 3 times P of 12 minus 2 times G of 4 times G of negative 5. Wow, okay. Either show your work or explain how you determined these values. So, you guys, what I'm going to do first is I'm going to find those values just at the top before I plug them in, okay, to this. Do you guys get how this is all review? Yeah, it kind of took everything from the last 5 lessons and put it into one. So none of this should be super hard. It just should be kind of nod your head review. Okay, let's find P of 12. Do we have an equation for P? Did they give us the equation? So I'm just going to plug 12 into that. I don't want to trust my graph. What if I graphed it wrong, you know? So let's do negative square root of 12 plus 4 plus 1. All right, so let's figure out p of 12. P of 12, square root of 12 plus 4, 16. And then plus 1. Okay, what's square root of 16? 4. So I have a negative in front though. So negative 4 plus 1. What's p of 12? Negative 3. It says either show your work or explain how you determine these values. Did we show our work? Yeah, beautiful. Okay. Now where are we going to get g of 4 from? The graph. So go find g of 4. What's the y value when x is 4? What's that going to be? 2? Good. And it says explain. Well, the point 4, 2 is on the graph. That's how we learned it, and that's how we're going to explain it. All right, g of negative 5. What's g of negative 5? So we're looking at the graph, and you go to x equals negative 5. Is it negative 4? Okay, and how did we find that? We looked on the graph. Okay, that's all the prep work. If you like to cook, you're a better cook or chef, you know, they do all the prep work first. It's called the mise en place, something like that in French. I don't know. So we just did the prep work, but we haven't even started the problem yet. So now we're going to find this value. Now the brackets in this case just mean multiply. Okay? You ready? Are you ready? Are you ready? Ouch. My feelings are hurt. 3 times. What's p of 12? Negative 3 minus, a 2 is already there, times g of 4. What's g of 4? 2. Okay. Times g of negative 5. G of negative 5 is negative 4. Double check your work. You got to check that you did it carefully. So I had a 3, p of 12 minus 2 times g of 4 times g of negative 5. Yeah? Okay, inside out. I'm not going to touch this negative 3 because we're supposed to do multiplication first. So what's negative 2 times 2? Negative 4. And then what's negative 4 times negative 4? So we're going to have plus 16. Okay, parentheses first. So negative 3 plus 16 is 13. And then finally we'll do 3 times 13 is 39. All right. Good job? Yes?